Hello, and welcome back to our discussion on background tasks. So in the recent videos, we talked about services, in that context also notifications and broadcast receivers, and finally async tasks. Um, Now we'll sort of take a step back and look at the basics of background processing as suggested or prescribed by the official Android documentation. Um, we'll look at the different types of Android background tasks and the recommended way of handling each one of them. And work managers and alarm managers are the two prime examples of handling these things, apart from what we have seen already. Um, so let's get there. As usual, first, some recommended readings. Um, First of all, the guide to background processing, as the name suggests, talks about these basics, guiding principles, and then the distinction or the categorization of background jobs, background tasks. Um, Work Manager Developer on Android Developer Guide, of course, introduces the Work Manager as the modern, sophisticated, um, sort of all-encompassing way of handling or scheduling jobs instead of having 3, 4 different types as they used to have until quite recently. The third bullet point here is a blog, rather a blog series on Android Developers blog. Um, it starts by introducing work managers, um, talks about why and when to use work managers, and then later in the series it goes into details uh, of a lot of things, including some advanced concepts. So a very good read, a very good sort of starting point for using work managers. The fourth bullet point is here about it's about scheduling alarms and using the alarm manager, which is one of the other ways of handling those different categories. Okay. So let's get into the basics of background processing. Um, so processing, I mean, basically processing data in the background is very important aspect of a lot of modern computing, uh, including Android applications. So there are a lot of things that you would want to delegate to a background task. Almost every um, popular, meaningful, useful, successful app out there has some network component, um, some data processing component. Both of these should happen not on the main thread because they can take a lot of time and hog the resources. So, um, you know, these following these best practices are underlying why it's recommended the way it is recommended, um, will help you keep your app responsive for the user, as well as a good member on the device of your users. And what I mean by that is your app should not be violating any understood aspects of performance, usability, resource management, etc. So following these guidelines and using these APIs will help you manage that in a very easy, straightforward, automatic way, instead of and you ending up doing a lot of juggling with um, low level concepts um, or dirtying your hands with those underlying threading and other details. So yeah, so the guiding principle is, and I quote from the developer's guide, any task that takes more than a few milliseconds should be delegated to a background thread. So that is the key. I mean, anything that can take more than a few milliseconds, right? So 10 milliseconds or 16 milliseconds are the numbers that we have seen for ANR, and that is the important aspect here. So what constitutes or what makes an app in the background? Two criteria. One, none of the activities of the app is visible. So um, the all the activities are in stopped state, at least, um, right? And no foreground service is running. So not even like the media player service that we saw in one of the recent examples. Okay, so if that is the case, then you are in background processing. Um, so what that means is, I mean, um, the media player service that we saw is actually a foreground service, because you have the icon up there in the notification bar, and even those are not considered for your app to be in background. Okay. All right. So here is a flow chart for deciding what category your task is in, and then there are recommended ways of handling each of these. So let's see, does the task require an active user? So, something that uh, the user is triggering or is quickly waiting for, etc. If your answer is yes, then you have what is called an immediate um, background task, right? It may be in background, but it's triggered by a user actively, or the user is waiting for it actively, and so on. Okay. If that is not the case, then you have another question to ask. Must it run at a given exact time? Um, like a reminder, right? I need to um, pay my bill on, say, first of the month at 9 a.m. So if I get that reminder at 9 a.m., I can quickly go online and pay my utility bill before starting the class, for example, right? So something like that. If that is the case, then it's an exact task. If that is not the case, then it's a deferred task. Deferred or deferrable task is something that can happen at a later point. It's not stuck to the um, current time, or a specific exact time. Okay. Um, and the documentation recommends handle immediate tasks using Java thread handlers. One of the examples is the executors, as we saw with the database examples in the database slides and videos, or use a work manager based on what exactly you're trying to achieve there. The exact tasks should be handled by the alarm manager, which we'll get to later. And the deferred tasks are also to be handled by the work manager. So it's the work manager that will devote the rest of this video to, and probably also, a good deal of the next video. Okay. So what is a work manager? It's an API mainly for the deferrable and reliable tasks. So what we mean by deferrable here, as we just saw in the previous slide, something that is not required to be done at this exact time. Something that can be done later. A good example is uploading the logs of your app, like what kind of interaction the user has done, uploading it to your app server, right? It can happen at a later time. It need not be done the very moment the the user is using it, but it should be done reliably. Like, you would not want to miss out on that data, and it has to finish at some point. So such examples are the prime candidates for scheduling things or using a work manager. Okay. All right. So until recently, Android used to have different mechanisms for scheduling, including a job scheduler, or a Firebase jobs dispatcher, or a GCM network manager. So Firebase, GCM, these are Google specific services. Firebase, as many of you perhaps know, is a database related service that handles a lot of other things, including messaging and such. And jobs scheduler is for mostly local jobs. But now, instead of having these three different APIs, um, what is happening and what is recommended is um, all of these are taken under the work manager. Work manager has its own algorithm internally based on which one should be. So I mean these three are not discontinued, but the end developer, end user of the APIs, that is the developer, need not use them individually. But work manager takes care of that based on the target SDK level, based on the type of job, it knows which one to use internally. So that's the key point here. And so Work Manager provides one simple and consistent API instead of three different ones. Okay. So to include Work Manager, add this line to your Gradle build dependency implementation Android X work runtime 240. As always, 240 is the current latest version. When you are using it, make sure that is the latest one by looking at the documentation or update it in your Gradle file. Work Manager has certain key features. So um, on top of integrating all these different APIs, it lets you specify the constraints. Um, for example, should this task run, say, only when you're connected to Wi-Fi, and not spend the user's LTE or phone connection that way. Okay. Um, there is robust scheduling. You can have one time or repeated scheduling. The repeated scheduling or periodic scheduling lets you specify the time gap between two scheduled instances. And it is also aware of things like doze mode, that is when the device is idle. There is a flexible retry policy. So sometimes the scheduled task just fails for several reasons. Right? Then maybe in the middle of it, maybe you lost the network or the server was not responding or anything like that. And then it gives you, the developer, flexibility of specifying, the backup policy or retry policy. By default, it's linear, but you can also specify exponential and parameterize it further. It also supports work chaining, which is really great. What that means is you can essentially specify dependencies among tasks, and when the next one should start, um, or rather when the next one, or what the next one is dependent on, and then making sure all the predecessors of the parent tasks are finished before the next one is started, and so on. You can specify parallel or sequential execution of tasks in a very simple syntax, very simple API. And it also takes care of passing the data from the parent tasks to the child tasks automatically for you. Finally, there is very good integration with other libraries like RxJava or Kotlin coroutines that have been published recently. And it creates a much richer and flexible environment. Right. So let's take a look at an example. Okay. So here is a class called worker, which um, which you'll have to extend and create your own worker to specify what you want to do. Okay, so it takes this constructor, which takes a context and worker parameters as its parameters. Simply calling the super class constructor suffices in most cases. Then inside that, you have to implement a single method, a do work, which is what will be done on background, right? So comparing to async tasks, it's similar. It had do in background. Here you have do work. So here, let's say, and this is a worker created for uploading images. So you are simply calling that method over here. Um, and when it's done, you call or you return a result.success. Um, so yeah, result.success is where you tell the work manager if the task succeeded or failed. So you have dot success. Similarly, you have dot failed and then dot retry for specifying the retry strategy if required. So this is an example of creating a worker. Next step is how to um, how to create or how to schedule this worker. Where does it go from here, right? So for that, you can create a work request. Um, that work request can be of two types. As I said in the recent slide, you can schedule a one-time request or a periodic request. The one-time request, both of them have similar syntax, but of course different classes. So here you are creating a one-time work request using its builder that takes the class name. You can specify additional configurations. We'll see in a second, and then finally call build to get the request. So this is a one-time work request example. For a periodic work request, as I said, it's fair. It's almost similar, but you get to specify a couple other things. So the periodic request or repeating request here lets you specify the duration of a repetition interval. So here, what we are saying is um, uh, take at least 1 hour before this task is repeated. Okay. Why does it say minimum duration and not exact? Because it depends on a lot of other constraints on the system, or any constraints that you may specify here in additional configurations. Um, there is a limitation on how low you can go here, and that is 15 minutes. And that is to prevent misuse um, of this or misuse of resources where people could have then otherwise scheduled things for every second and hogging all the resources. So to prevent anything like that, there is a minimum of 15 minutes. You cannot schedule repeating tasks for less than 15 minutes. All right. So that's about creating a worker and creating a work request from that worker. We'll talk about constraints and some other things in the next video. Thank you.